Hi guys, it's me, Miss Miller, and today we're going to continue with section 4.3, Properties of Logarithms, Condensing Logs. So before we expanded making the expression bigger by their properties, now we're going to take a larger expression and condense them. It's important to remember order of operations and to work step by step. So here is our first example. Again, you're going to use the properties I introduced to you yesterday. So I have here 1/2 times the log of x plus, and we know that that plus sign means our our product property, 3 times the log of x plus 1, all in parentheses. So what I'm first going to do is simplify this expression by taking my 1/2 and raising it to the x, as well as 3 is going to raise the x plus 1. So I'll end up with log of x to the 1/2 power, which we should know that that is your square root, plus log of x plus 1 to the third. Now again, this plus sign means our product property. And because our logs are common logs, they have the same base, I can now multiply. If these were not the same base, then I couldn't condense them. So now I have log x to the 1/2 times x plus 1 to the third. There is no need to expand this expression and make it into standard form for a polynomial, but what you might see is log square root of x times x plus 1 to the third. Now we know that we should not distribute square root of x to x and square root of x to 1 because this third power is higher than a multiplication. So this here would be your final answer. All right. In our second example, we're going to do the same thing. We're going to use our power property. So I have our natural log of x minus 2 squared minus the natural log of x. Almost treat each log expression as its own thing. So if you can condense it because there's multiplication going on, do that. So we're going to make it to the power property. Now with subtraction, we know that that is our quotient property. Natural log, both with base e, so they're the same. So I can condense to being natural log of x minus 2 squared. The first term again is my numerator, divided by x. It's really important that you do not, we all know that I struggle here, do not write natural log of x minus 2 squared, natural log of x. This is not the same as this. If you want, you could put parentheses around this whole thing, but it's not necessary. Natural log over natural log is not the same as natural log of the whole thing. All right, here's another example. Notice that there's two things being subtracted. I talked a little bit about this yesterday, that what you're going to need to do is factor out the negative because you're subtracting and subtracting. So what's actually happening is 2 log base 6 of 5 minus 10 log base of 6 of y squared is actually being added together. There's more than one correct way of tackling this, but I'm going to show you what I would do. So this is 1/4 log with base 6 of x minus parentheses 2 log with base 6 of 5. Now it's a plus sign, 10 log with base 6 of y squared. Now I can use my power property and bring all of these exponents back to their original place. So I have log with base 6 of x to the 1/4 minus log with base 6 of 5 squared plus log with base 6 of y, and now that'll be the 20th power because you're going to multiply 10 times 2. When I take a look at this, I'm going to condense what's in my parentheses. So I end up with log with base 6 of 25, because 5 squared is 25, And then this becomes multiplication, y to the 20th. Log with base 6, x to the 1/4. Now, because of the subtraction, we know it's the quotient. So now I condense to one logarithm, log with base 6, and it's the 4th root of x over 25y to the 20th power. Again, if you want to put it all in parentheses, remember that it's a single logarithm. It's not log over log. All right, let's pay close attention here. What's really important to look at is that these square brackets. These square brackets tell me that I'm going to do this first before raising anything to the 1/3 power or distributing. Now you could distribute 1/3 to all three logarithms, but that's not necessary. What I will do again is factor out that negative. So I have 1/3. This is a challenging problem. 4 times the natural log of x plus 5. Again, you can kind of do this in any order you want. I'm tackling what's more difficult first. So I'm subtracting the whole quantity, natural log of x, plus the natural log of x squared minus 25. Square bracket. Now I'm going to use my power property. So I have 1/3, square bracket, natural log x plus 5 to the 4th minus, and now I'll condense with my product property, the natural log of x times x squared minus 25. Now, some of you might be thinking x squared minus 25, parentheses, x squared minus 25 and x plus 5 have a common factor. And we're going to see that comes into play with this division or our quotient property because we're subtracting. So again, 1/3 natural log, and now I have x plus 5 to the 4th power over x times x squared minus 25. If you want, so to keep this simplified, again, I said this is a more challenging problem. I'm going to notice that x squared minus 25 is x plus 5 times x minus 5. So I'm going to simplify by canceling out one of these for each. So I end up with a natural log of x plus 5 now to the 3rd power because I removed one over x times, I removed one of the x plus 5's, x minus 5. Now all of this gets raised to the 1/3 power. So I end up with the natural log of x plus 5 to the 1st power because 1/3 of 3 is 1, x to the 1/3, x minus 5 to the 1/3. We did expanding yesterday, but here's another example if you want to practice. Here's another example of condensing. If you'd like to practice, I can go over those answers with you. But the other property that's in the section I want to talk about is for change of base. If you look first at the examples, not the property, but if we first look at these examples, log with base 5 of 140 is not something you can actually find. 5 to some power of 140 isn't possible. Only common logs and natural logs are able to do in your calculator. So what we use is change of base property. And what that says is you take your base and you're going to take some log. So a lot of times we do our common log. So it would be log of m over log of v, or you can do your natural log because both of those are in your calculator to evaluate. So at this time, you should take out your calculator. So if I want to rewrite this, my base is 5, and I'm taking the log of 140. So I can do the log of 140 divided by the log of 5. Notice that this isn't one logarithm, but actually 2. So if you take and do the log of 140 you get 2.146. And if I do the log of 5, I get 0.69. We'll round up and say 9. So 2.146 divided by 0.699. Now you could do this all on your calculator at once, but again, I'm just trying to show my work, equals 3.07. You could have also done the natural log. Oops. Natural log of 140 divided by the natural log of 5. You'll get different values. So the natural log of 140 is 4.942. And the natural log of 5 is 1.609. But what you'll notice is when you divide, and I'm doing it as I talk to you, 4.942 divided by 1.609, I still get 307. It's important to give 307. It's important to give 2 decimal places to have a more exact, which makes sense because 5 to the third is 125. So a little bit more than to the third would give you 140. So the same thing here, log of base 7 of 2,506. That's not something we know the value of. So again, I'll switch it up and I'll do the natural log first of 2,506. And it's always what you're taking the log of divided by the natural log. So now, with your calculator, we can take a look. Again, the only way you can evaluate these things and estimate their value is by doing it by natural log or common log. So 2006 natural log gives me 7.826 divided by the natural log of 7, 1.946. When you actually divide those two things, you get 4.02. Now, you do not need to do both methods, doing the common log and natural log. You can just pick whatever one you prefer. I just wanted to show you that works for both. You get the same answer, even though you get different values for natural log and common log. I hope this was helpful. And if you have any questions, as always, feel free to email me.